Let me ask you a question. What is a prime number? A number that is divisible only by 1 and itself. Sounds simple, right? But here's the interesting part. How do we check whether a number is prime using logic in C? Is there only one way, or are there many smarter ways? Let's find out. Welcome back to this playlist, One Problem, Many Logics in C language. In this series, we take one simple problem and solve it using multiple approaches to improve logic building. Let's begin. Problem statement. We are given a number. Our task is to check whether the number is prime or not. Before writing any code, let's understand the concept clearly. Prime number concept, very important. A prime number is a number greater than 1 that has exactly 2 factors, 1 and itself. For example, 2, 3, 5, 7, 11 are prime, but numbers like 4, 6, 8, 9 are not prime because they have more than 2 factors. Now, let's convert this idea into logic. Logic 1. Basic method. Check all divisors. This is the most straightforward method. We check divisibility from 2 to n-1. Int I, flag, equals 1. If num smaller or equal to 1, flag equals 0. For I equals 2, I smaller than num, I++. If num modulus I equals 0, flag equals 1, break. If flag, printf, prime, else printf, not prime. How does this work? If the number is divisible by any number other than 1 and itself, it is not prime. This logic is easy to understand, but not very efficient. Logic 2. Optimize the loop up to n/2. Now, let's optimize the previous logic. A number cannot have any factor greater than n/2, except itself. For I equals 2, I smaller than or equal to num/2, I++. If num modulus I equals 0, flag equals 1, break. This reduces unnecessary checks. Better than the first approach, but we can do even better. Logic 3. Most efficient loop up to square root of n. Now comes the most important logic. If a number has a factor, at least one of them must be less than or equal to the square root of the number. For I equals 2, I times I smaller than n, I++, if num modulus I equals 0, flag equals 1, break. Why does this work? Because if both factors were greater than square root, their product would exceed the number. This is the method used in real competitive programming. Logic 4. Using function, clean approach. Now let's move logic into a function. This improves code readability. Int is prime int num. Int I, if num smaller than or equal to 1, return 0. For I equals 2, I times I smaller than or equal to num, I++, if num modulus I equals 0, return 0. Return 1. This approach shows how to reuse logic cleanly. Logic 5. Special case optimization, smart thinking. Now let's add more intelligence. 2 is the only even prime number, so after checking 2, we can skip all even numbers. If num equals 2, printf prime. Else if num smaller than 2 or num modulus 2 equals 0, printf not prime. Else, for I equals 3, I times I smaller than n, I++, if num modulus 3 equals 0, printf not prime. Return 0. Printf prime. This reduces half of the checks and makes the program faster. Final comparison. So, which logic should you use? Pause. For beginners, basic loop logic is fine. For interviews and performance, square root optimization is the best. For clean and reusable code, function-based logic is preferred. Different logics, same answer. That's real programming. If this video helped you understand prime numbers better, like the video and subscribe to the channel. This playlist will transform the way you think about programming. Until then, keep learning and keep coding.